Now let's start to handle some typical questions. Example 2. Flowing dust. Dust is projected horizontally with an initial speed of 8 meters per second towards the bullseye. The dartboard is 2.4 meters away and its radius is 0.23 meter. When the dart is projected, it is a projectile. And then the most important question is, how long does it fly? What determines the time of flight? The answer is the 2.4 meter separation. If it is shorter, then the dart will fly for the shorter time. If it is longer, then it will fly for the longer time. So we apply equation for horizontal uniform motion to calculate the time of flight. It takes 0.3 seconds for the dart to reach the dartboard. And then you may substitute this 0.3 seconds to be the time of flight into the equation for vertically accelerated motion to calculate the vertical displacement. And now the next similar question. Example 3. Bombing. The bomber flies with a horizontal velocity of 150 meters per second to release a bomb. Due to inertia, the bomb will have an initial horizontal speed of 150 meters per second. The bomber is at a height of 2,000 meters above the sea and it targets at an enemy ship on the sea. So how far the bomb will go before it hits the enemy ship? So the most important question is, again, how long does it fly? What determines the time of flight in this case? The answer is the 2,000 meters. It takes longer to reach the sea if the bomber is higher. It takes shorter time if the bomber is closer to the sea. So we use the equation for vertically accelerated motion in order to find the time of flight. And we find that the bomb takes 20 seconds to reach the sea. So the bomb travels horizontally for 20.2 seconds. And so it travels 3,030 meters away. For part B, you have to find the velocity of the bomb when it hit the enemy ship. You have to find the vertical speed when it is on the sea. And horizontal speed never changed. It was 150 meters per second. You have to combine the two together into one to find the resultant using Pythagoras theorem. In fact, when a bomber releases a bomb, the bomb will have the same horizontal speed as the bomber. So the bomb will always be underneath the bomber. And if bombs are released at regular intervals, the bombs will line up themselves underneath the bomber with their separations in ratio of 1 to 3 to 5 to 7 and so on. On the other hand, if the bomber accelerates, then the bomb will be behind the bomber that will land on point A instead. And now please try check point 2 and the multiple choice questions in practice 8.1.